3. I mean, 3, 3, 1, 3, 3, 2, and 3, 3, 3 all have to do with solving equations and different ways of looking at equations. I think it's a good section of the book that kind of makes you think about things. It does start with a little bit of a review, and then it kind of jumps into it. So this one, it says, would you use distributing or area models? Well, this one's a 2 by 2, so probably an area model is a 1 by 2, so we could probably get away with distributing. So hopefully we feel comfortable with these things by now. I would get 12x squared there. Oh, that doesn't look great. I should probably make this bigger, sorry. So 6x minus 11 and 2x plus 5. I get 12x squared. Here I'm going to get 30x. Here I'm going to get minus 22x and minus 55. So I get 12x squared plus 8x minus 55. On this one, again, they're saying it's a 1 by 2, so you may as well just distribute. Negative times a positive is negative. 2 times 15 is 30. 2 x's and 2 more x's is 4 x's. Here, a negative times a negative is positive. 2 times 3 is 6. 2 x's with a y will look like this. All right, so different methods to solve an equation. So it says to be prepared to solve unfamiliar equations, it helps to examine all the solving tools you currently have. So consider this equation. Your task with your team is to come up with at least 2 different ways to solve this. So it'd be great if you'd pause the video and think if you could think of a couple different ways to solve it. So long story short, there's actually at least 3 different ways, if not more, to solve this problem. So one, the book calls rewriting. And essentially with rewriting, what you're doing is you're just going to sort of distribute this 4, which is probably what a lot of you guys did. You probably decided to do this, subtract 12 from each side. I'm kind of running out of room, so I'll go up here and get 4x equals 8, so x equals 2 once I divide both sides by 4. So a lot of you guys probably did that. One of my favorite ways to solve a problem like this is what's known as undoing. And undoing is you go the opposite order of operations. So the first thing I do is add 3, then I multiply by 4. So, so I'm going to undo that. In order to get rid of the multiply by 4, I'm going to divide by 4. And in order to get rid of the add 3, I'm going to subtract 3. So I'm going to go over here, I'm going to divide both sides by 4. And I'm going to get x plus 3 equals 5. And then I'll subtract 3. And you can see I still get x equals 2, just like I did up here. 2 totally different ways of solving, but getting the same answer. And the last one is looking inside, which is kind of a nice shortcut. You're saying, hey, look, 4 times, if this parenthesis equals 5, 4 times 5 is 20, right? So if the entire parenthesis equaled 5, I would get 20. So I'll just say x plus 3 is equal to 5, and I get x equals 2. And that strategy is known as looking inside. So any of those 3 methods is going to get us the same answer. So as we continue along, we will get here. Again, we've kind of talked about all those. So now we're down to this. We want to match up here. It says the 3 methods. So we want to match up with what's going on here. So this one we're saying if 5 to the 8x equals 5 to the 24th, then, well, I know that 8x must equal 24. That's kind of like looking inside, right? We're sort of looking and saying, let me think about this problem more deeply and look for a really good shortcut. So that's looking inside. Subtracting is the opposite of adding. So for this one, I can begin by subtracting 4 from both sides. Well, that's undoing, right? You're doing the opposite of what's there. So the last one must be rewriting. This problem might be easier if I turn it into, and there we go, we distribute that 4. We're rewriting the entire problem. So I think that's how those things are going to match up with the definition with the description. All right, and then finally it says let's solve these by rewriting. So I guess we can kind of do these one at a time. On this one, I get 5x squared plus 43 is equal to, well, I'm going to rewrite this. This looks kind of crazy, so I'm going to just go to an area model over here and make this easier for myself. I'll get 5x squared. I'll get 6x minus 5x minus 6. So this equals 5x squared plus x minus 6. Hopefully you guys see 6 minus 5 is 1. I'll subtract 5x squared from each side, and I'll add 6 to both sides. So that's going to cancel and leave me 49. That's going to cancel and leave me x, and that's going to cancel, so x equals 49 for that problem. Now I will go ahead and I will do problem B. Problem B, again we can rewrite, and again I'm gonna rewrite both sides. First I'll do the area model here. Don't forget, this just means when you see x plus 3 squared, it just means it's x plus 3 times x plus 3. So I'll put this in an area model, and I'll get x plus 3, x plus 3. I get x squared, 3x, 3x, and 9. By the way, a lot of kids will look at this and just say x squared plus 9. And you can see why they would. They go, oh, look, x times x is x squared, and 3 times 3 is 9. But they omit this 6x right here. So you want to make sure you have that whole part of it. So x squared plus 6x plus 9 is equal to, and again I can rewrite this. I'm going to get x squared, I'll say minus 3 plus 3x. So I've rewritten the left side and I've rewritten the right side. And now I can just combine. I'll subtract x squared from both sides. I'll subtract 3x from both sides. And I'll subtract 9 from both sides. These are going to cancel. This is going to leave me 3x. These are going to cancel. These are going to cancel. It's going to leave me negative 12. And these are going to cancel. I'll divide by 3 and x equals negative 4. By the way, you'll see I didn't plug 49 in and solve these. I guess I could have and saw what I got there, but that was going to be pretty big numbers. On this one, it's pretty easy to check, though. Negative 4 plus 3 is negative 1. Negative 1 squared equals 1. Here, negative 4 squared is 16. And then 1 minus negative 4, that's like 1 plus 4 is 5. So negative 3 times 5 is negative 15. So 16 minus 5 does equal 1. So I checked that one. I should probably check A. I'll grab a calculator and check A. So A, I got x is 49. So I'll say 49 squared times 5 plus 43. I get 12,048. On this one, I'm going to get 49 minus 1 is 48 times, this is like 5 times 50 is 250, so this is going to be 245 plus 6 will be 251. So what I'm hoping is that 48 times 251 will equal this. And it does, so there I checked that answer too, although I didn't want to check this one without a calculator. All right, and then finally we will rewrite, easy for me to say for the last one. So again, I will just distribute here. I'm going to get positive 4x squared minus 2x plus 10 equals, well, think about this. This is 8x over 4y squared. So I'm going to get 64x squared over 16y squared. Well, if you think about that, that's going to simplify just the fractions, and it's going to be 4x squared over y squared. So I will call this 4x squared over y squared times, remember, a negative exponent moves to the top and turns positive. So it's going to look like that, which looks crazy, right? So I'm at 4x squared minus 2x plus 10. I won't do anything to the left side, but to the right side, these are going to cancel. It's just going to equal 4x squared. So I will subtract 4x squared from both sides, and I will subtract 10 from both sides. These will eliminate. I will get negative 2x equals negative 10. I'll divide by negative 2, and how boring is that? X ends up equaling positive 5. So x equals 5 in this one, which is probably not what we would have considered. And again, let's see if we can check our answer there. We know these y's eliminate, so y doesn't need to equal anything. These y's are all going to go away. So what I'm going to get here is 40 squared. So let's see what 40 squared is. I'm doing the right side first. So 40 squared, I think it's 1600. Why am I doing this? So there we go. We get 1600 on the right side. And then on this side, I'm going to plug 5 and I get 25, right? 25 times negative 2 is negative 50. Negative 55 plus 5, so I get negative 50. Oh, I got a problem here. So 25, negative 50. Negative 50 plus 5 is negative 45. Minus 5 is negative 50. And negative 50 times here is positive 100. So I did have a problem here with the x. I do need to solve for the y. I guess I was wrong. I'm going to need to do a better check on this. So let me pause this and see what's wrong with me. Into this, you can see x equals 5 and y doesn't equal 0. I incorrectly assumed I could just ignore that 0, and I can't. Y can equal anything in the world it wants to equal but 0. So that does sort of affect things. It gets into a branch of math that you're not going to talk about for a couple of years at least. But the bottom line is, let's say I made this 1. And I think that was my problem, right? As I just made it disappear, and I can't just randomly make it disappear. So if I want to make y equal 1, as long as it doesn't equal 0, I'm fine. And 1 doesn't equal 0, and it'll make this way easier. So I'll plug a 5 in here. So I get 40 over 4 squared times 1 squared. And what I'll get is 10 squared times 1, which is 100 times 1. So that does work. So I did have the correct answer that x does equal 5. I should have kept going. Y can't equal 0. By the way, why can't y equal 0? What happens if I plug a 0 and you get 0 on bottom and that breaks everything? So as long as y isn't 0, the y's will cancel. If it's 2 or 3 or 4, they'll cancel. But if it's 0, then everything falls apart. So again, that's, I think, something you're going to talk about in integrated 3 or in calc. All right, let me pause here. So I don't know why I'm pausing there. I think I thought that there was more problems, but we went through 313. There were some math notes, and then there you go. We started the homework, so we were done with the video. Sorry.